Okay, hello. Let's do a couple more questions from 8.6. This is 5F, and what we're looking at with the scrappy graphs is this symbol. But for now, we're going to forget about that symbol and just think about the scrappy graph for a second. We've got an upside down parabola. That's all we care about. So upside down, we don't know where. And then we're going to look here. So less than, which is going to mean under the 0 line, which is the x-axis here. That's what that whole little sentence means. So we want to know when that occurs. And if the x value is here, it is right on the x-axis. If the x value is here, then we'll end up with a y value or the graph under the x-axis, which is what we're looking for. Same on the other side. So now to find those points, we're just going to factor. So what if we have 6 and 4 and x, one of them plus, one of them minus, and yes, okay. So 6 plus x and 4 minus x is supposed to be less than 0. And notice, like, we can't tell from here, should we put 6 is greater than x or 4 is less than, we don't know. So this is how this works. We know we've got, this is at, x is going to be -6 and x equals 4 from this part. So that means this is 4 and this is -6. Those are the intercepts. Then for our statement of when the graph will be less, we know here, so x has to be less than -6, and x has to be greater than 4. Those would be open circles, I guess, if we're graphing that, but we're not. Okay, next one. So let's think. Now we can do this a little quicker. So we've got a parabola right side up, and we want when is the parabola less than the x-axis, so less than 0. And now I'm going to factor. So x and x, 3 and 1, negative, negative, yep. So x minus 3 and x minus 1 less than 0. My x-intercepts are going to be here at 3 and here at 1, and who cares that it doesn't look like that. But what I care about is that underneath the x-axis, I have my graph, which is what I'm looking for. So I need my x's, if I choose numbers, they've got to be in between those two. So 1 is less than or equal, nope, just less than, x less than 3, and I'm done. D part. Okay, so my graph, I've got a right side up parabola. And I want, when is that parabola, or what values of x will give me a y value that is greater than 0? That's really what that's saying. So here, and now let's factor. I can pull that out in x plus 4 greater than 0. So I know this is 0. Well, and that doesn't look like 0 at all. How about I just move my line to there. Ta-da! Now it'll work. Okay. So 0 and -4 from here for my x-intercepts. So I need this section. So x has to be less than -4. So any value of x I choose that is less than -4 will give me a y value that is greater than 0. And x is greater than 0. Typically we don't put these together like this format of writing it because they're outside, so usually we just do the insides. Okay, last one. This guy, we have a parabola that is upside down, and it'll go through something nice. We'll worry about that later. Maybe I won't do the the y-axis. I'll just leave it and wait. Okay, so upside down parabola, and I want when is my parabola, or what values of x will give me a y value that is less than or equal to 0. So I want under the y-axis. I'm going to pull out that negative before I do anything, so 4x squared plus 8x minus 21. And now 3 and 7 plus and minus 2 and 2. How about that? Negative 14 plus 6 if I do the other way around. Negative, positive, and now I've got, yeah, that'll give me plus 8. So negative out front, 2x minus 3 and 2x plus 7. Supposed to be less than or equal to 0. So I know my x-intercepts are going to be 3 over 2. And really we shouldn't be writing equals. These are just the intercepts. 3 over 2 and negative 7 over 2. So here we are, 3 over 2 and negative 7 over 2. So, ta-da, for my y-axis. And this is why they're called a scrappy graph. And now I can write. I need x to be less than or, yes, equal to negative 7 over 2 and x to be greater than or equal to 3 over 2. Ta-da!